You're going to be writing down notes on Section 5 of Chapter 10, which is scientific notation. So remember, you can pause the video if you need to write down the notes. You can rewind when you need to hear something again, and then hit play when you're ready to move on. If you have a question or something you don't understand, please write down a note in your notebook that we can then go over during class tomorrow. You don't need to understand everything completely. I just want you to have some background information, so tomorrow when we do some practice problems and go over the material again, you know what we're talking about. So go ahead, get ready to take some notes. So this is on scientific notation. So first, what is scientific notation? Scientific notation is used to write a very large and very small numbers, and I'll give you some examples of that in a minute. How do we write scientific notation? Well, scientific notation is a number is written as a power of 10. And again, I'm going to give you an example, so just write this down for now. The number that I use must be between 1 and 9. So here are some examples. So let's look if this is written in scientific notation. So I want it as a power of 10. So here's my power of 10. And I must have a number between 1 and 9, and I have a 3. So in my 1 spot, I have a 3. Here again, same thing. I have the same thing, 3. But this is times 10 to the negative 9th power. So when I have something that's times 10 to the 9th power, that's a very large number. And when I have something to the negative 9, that's a very small number. And we'll show you later how to actually utilize those negatives and positives of the powers. So go ahead and write this down for now. So the first thing we want to do is just be able to recognize whether we have scientific notation or not. So write down example 1, identifying scientific notation. So I'm going to give you a couple numbers, and you're going to see if it's really written in correct scientific notation form. So we're going to decide if the number is written in correct scientific notation form. Here are my 3 examples that we're going to look at, and we're going to evaluate whether they're written correctly. So we have to go back to the rules. So is it using the power of 10? So in A, yes it is. And in the ones place, my number is between 1 and 9. So yes, that's written in correct scientific notation. My second number, I have power of 10, but this is not a number in the ones place between 1 and 9. So that is not written in correct scientific notation. Let's look at our last one. We have times power of 10, correct? But I do not have a number between 1 and 9. I have 32, so you always have to look to the ones place. So no, that one is not written in correct scientific notation. So now we're going to practice writing numbers in standard form. So what does standard form mean? So if there was that negative exponent that we looked at, we're going to move the decimal to the left because we want to make a small number, making the value of the number smaller. So write that down. So here's my example. I have 4 times 10 to the negative 4th. So what I've done is, for me to do this, I write down my 4, and then I actually make little loops to show my decimal moving 4 places to the left. So I've moved it 1, 2, 3, 4. Then I add all my zeros. I put my decimal. And we kind of want to put that 0 in front as a placeholder. So that's how we write in standard form, and that's how we utilize times 10 to the negative 4th power. Sorry about that, I pushed the wrong button. So that's using the negative exponent. So next we're going to show you how to use a positive exponent. Okay, so we saw what happens when we have a negative exponent. So what happens when we have a positive exponent? So remember, you're writing all this down. If there's a positive exponent, you're going to move the decimal to the right, making the value of the number greater. So if we look at the same thing, 4 times 10, but we're going to make it to the positive 4th this time, is the same as 40,000. So that's because if I take my 4 and I do like before and I move my decimal, 1, 2, 3, 4, and I find if I make those little loops, it helps me. Put all my zeros in. There's my decimal at the end. So that shows me that I have 40,000. And please make sure to use commas. It's a lot faster to see that 40,000 than to have to count all those zeros to figure out where we're at. Okay, so we're going to practice some of these. So this is example 2, so copy this down and then we're going to practice doing this. So I'm writing in standard form, so I'm going to take my 3.22 and I want to move my decimal 4 places to the left because I want to make my number smaller. So I'm going to go 1, 2, 3, 4. I'm going to add my zeros. And I'm going to put a decimal and a 0 kind of as a placeholder. So my final answer is 0.000322 because I moved my decimal 4 places to the left. Now in example B, I'm times 10 to the 5th, which is to the positive. So I know I need to make a bigger number. So here's my 7.9. I need to move my decimal 5 places. So that's 1, 2, 3, 4, 5. I'm going to add my zeros into those loop-de-loops. Put my decimal at the end. I can put a 0 at the end if I want to keep a place, but I don't have to. It's not as much as in the front. And I'm going to add my commas so that I can recognize what my final answer is. My final answer is 790,000. So now you're going to try some of these on your own. So let's start with this one. Please copy this down into your notebook. Is 12 times 10 to the 4th in scientific notation? Sorry about that. I forgot to make that as an exponent. Oops. Go in the wrong direction. Okay, let's try this again. Sorry about that. So this should be 10 to the 4th power. Is this in scientific notation? If not, how could you write this in scientific notation? So write that in your notebook. And then you should see a text box to the right. You can write your final answer in. And if you're going to write this in scientific notation, you can use an EX to say that's your exponent. So you could do 10EX and then write down what number you want to put in there. Okay, so try that, and then I have a couple more for you to try as well. Okay, you're going to write these 3 in standard form. So remember, that's getting rid of times 10 to the 7th. So if it's a positive exponent, you want a bigger number. If it's a negative exponent, you want a smaller number. So again, you should see a text box on your right. Go ahead, pause the video if you need to. Calculate your answers in your notebook first, and then put them into the text box and move on when you're ready. Now we have example number 3. So we're going to look at comparing numbers in scientific notation to figure out which number is bigger and which number is smaller. So you're writing this down. So if I know the density of water is 1.0 times 10 to the 3rd kilograms per meter cubed, and that's not important, we just want to make sure that we always have the same units when we're comparing something. So we want to compare the density of water, which you maybe looked at in your science class. So if an object is less dense than that, it should float. So that means it has a smaller number than 1.0 times 10 to the 3rd kilograms per meter cubed. And if an object is more dense, so it's a number greater than 1.0 times 10 to the 3rd kilograms per meter cubed, it will sink. All right, so we're going to decide if the following will float or sink in water. So let's look at a couple of these. We're going to look at an ear of corn and a diamond. Now, you can probably guess before you even get started which ones are going to sink and which ones are going to float. But let's actually look at our numbers. Here we have times 10 squared. Is that less than or more than 10 to the 3rd? Well, it's a smaller number. So if it's smaller, it's less dense. So that one's going to float because this number is smaller. Now let's look. We have 3.59 times 10 to the 3rd. Well, that's the same. So now I'm going to look at the first part of my numbers. And here I have 1, and here I have 3.59, which is a bigger number. So that is, if an object is more dense, it will sink. So this one's going to sink because this number is bigger than 1. Okay? So now you're going to try some on your own. Okay, so copy these down into your notebook. You're going to try these on your own. So are they going to sink or they're going to float? So if you remember water, the density of water, we stated, but I'll rewrite it again, 1.0 times 10 to the 3rd kilograms per meter cubed. So you want to decide, are these numbers bigger than or less than this, 1.0 times 10 to the 3rd kilograms per meter cubed? If the number is greater than this, if the number is greater, it's more dense and it will sink. If it's less, the number will float. So again, you should see a text box on the right. Write your answers in there for A, B, and C. Honey, Pluto, yes, the pseudo-planet Pluto, into olive oil. And tell me what's going to happen with those. Okay, now we have everybody's favorite word problems. So here's my word problem. If a dog has 50 fleas, how much blood do the fleas consume each day if one flea consumes 1.4 times 10 to the negative 5 liters per day? Okay, so first we kind of have to figure out what numbers we need and what we're doing. So I know we have 50 fleas. So I have to take all those fleas and multiply that times how much each one flea can consume each day. So if I multiply 50 times that, I'm going to do that in little steps. So first I'm going to do 50 times 1.4. That gives me 70. And then I can just add on to the end my 10 to the negative 5. But is that in correct scientific notation? Gosh, no. So I need to move my decimal one place. So now I know 7.0 times 10 to the negative 4 liters. So if I put that in standard form, you can see standard form right here. So here's my standard form. And if I convert that, I can convert that to milliliters, which is 0.7 milliliters. Because if you remember, 1 liter equals 1,000 milliliters. So if I take my 0.007 times 1,000, I get 0.7, right? Okay, one more on your own problem. So we're doing the same thing. What if a dog has 75 fleas? How much blood, I know it's gross, do the fleas consume in one day? Do like we just did as liters and as milliliters. And just as a reminder, remember one flea consumes 1.4 times 10 to the negative 5 liters of blood each day. Yuck. Okay, you should see a text box on the right. Go ahead and insert your answer, and we will see you tomorrow.